Thanks for the introduction. And folks, welcome to the cloud computing session today. And good morning to you all. And I'm Ram Krishna. I'm a senior solutions architect. I work for IBM. And then, let me give a brief about who I am, and then we'll get deeper into the session. So I've been working as a software engineer, as a architect and engineer for more than 25 years. And what I really love about technology is kind of teaching. It's like whenever I hear about new technologies, new evolutions, and I pick it up and then kind of in a way to let everybody know or teach the technologies and then create awareness. So today's session is predominantly about cloud technologies, and my foray into cloud technologies began in 2013 when I started working for HPE. And at HPE, we were trying to develop a private cloud platform using OpenStack. So if you want to have your own kind of an Amazon cloud kind of a thing, let's say in your own house, for example, right? You can pick up some storage servers, you can pick up some machines, and then using OpenStack, you can have your own Amazon style cloud within your own house. So, I mean, that's a wonderful thing. So that's where I started. And then I eventually moved to working on containers and Kubernetes. So that's my cloud journey. And I have bachelor's in computer science. And I also have an MBA from Santa Clara University. And aside of my work, I am a hiker and then a movie lover, and I follow tennis and soccer. And I have my own Twitter. I don't tweet that often, but you're free to follow. Okay, so let's get in depth. So what's the agenda for today? So today we're going to talk about what cloud is. We'll go a bit deep into what technologies are used in cloud, and we'll talk about the history and the evolution of the cloud. And we'll look at briefly into the public cloud and the market that we are in. And we'll also talk about virtualization, because virtualization is very important from a technology standpoint, because virtualization is what fueled cloud technologies. So without virtualization, there's no cloud. And then we'll talk briefly about containerization and Kubernetes. So we'll also talk about what containerization is and Kubernetes is. And these two are very vital, simply because what's happening in the cloud, if you look at, it's all about containerization. And then we look at Google Cloud Services. So why specifically Google? Because I'm a Google certified cloud architect, and I'm passionate about Google Cloud Technologies. Although I don't work in Google Cloud Technologies, but I work in other competing technologies very similar to what Google provides. And then we will I'll walk you through a demo of Google Cloud Console. So Google Cloud Console is how you access all the Google Cloud functionality. We will not go into depth given the time constraints. We will look into what briefly some of the technologies what Google Cloud provides. Okay, and then we'll wrap up the session with question and answers. So what exactly is cloud? I mean, these days you see advertisements, you're driving by and you see cloud technology, and then it's all about it's all like a fuzzy thing for a lot of the common man, and then even for some of those who are already in the technology space, cloud is somewhat ambiguous. I mean, they don't know whether some particular service is cloud based or on-prem. Okay, so cloud computing is the use of hardware and software to deliver a service over a network. So that's typically delivered over the public internet. Now, okay, that's so far good. Okay, you can access this service, whatever it's called, over the internet, but what exactly is it, right? So you can achieve that same thing, cloud computing, using what we call software as a service, platform as a service, and infrastructure as a service. Now, it could be a bit vague at this point, but we'll get deeper into it. Now, let's look at how cloud has evolved over the years. Now, if you look at the 1960s, if you recall time sharing, even during my early career in the 90s, time sharing was common. Somebody raised hand. I don't know. Is it a question? About a question? I don't know. So John McCarthy introduced mainframe time sharing, and those of you who can recall, it's about you sit. Most of the users sit in front of a dumb terminal and then enter some commands, and then these are executed in a server, either on-prem or remotely in some corner of the world. That's how it was, in 60s, 70s. It was mainframe time sharing, and then ARPANET came out in 1969. That's when different machines got networked together, and then being able to talk together. And it's around the same time somebody sent the world's first email, "Hello, how are you?" kind of a thing, from completely two geographically far apart locations. And then you have 1970s, www was launched. Sorry, 1970s we had virtualization coming up. It was still in a nascent stage, because although virtualization came about, it's kind of still primitive, and it's still on single machine kind of a thing. So it's not about being able to share resources across. And then the internet came along, and then in 1997, some gentleman by name Ramnath Chellappa coined the word cloud computing. Now, what he defined, it's no longer relevant, because the definition and what it means has changed dramatically. So we'll not talk into how he defined cloud computing as. And then in 1999 came Salesforce. Salesforce was the first software as a service company. So what Salesforce was doing is it hosted some applications on its website, and you can access and pay access to the service by usage, and you don't own anything. So that's the first cloud offering. Now you should also remember that around this time, a lot of data centers came up, were being set up, and primarily these data centers were not exactly cloud providers, but they were only hosting your machinery on their premises, so that you don't have to clog your own real estate with any kind of hardware. So data centers were also secure, and then they also provided 24/7 kind of a service. So, but they're not exactly cloud. So, and then sometime between 1999 and 2006, VMware, it's a Dell subsidiary, and VMware is a very well-known company, and VMware came up with hypervisors of their own. And then they started virtualizing storage, and they started virtualizing network, and pretty soon, so many virtualized storage companies came around. So that was kind of the beginning of, a kind of a fragmented cloud solutions. And then in 2006, Amazon launched the first cloud option for storage. I think Amazon offered storage first, and then EC2 came along. And there's a bit of a story behind, there's a history. Apparently, Jeff Bezos, in the process of building his company, he bought himself huge amount of hardware infrastructure, and then soon he realized that, okay, I have bought too much of it, so he didn't know what to do with it. And just then around, as timing would have it, virtualization started, and then he started implementing virtualization on his servers, and then AWS came along. Okay, so AWS was the first public cloud company. And then soon enough, sometime in 2013, Google was already working internally. They had their own cloud. Everything was cloud for them. And then they started making some of their services public. And just a year before that, it was Microsoft came with Azure. So by 2014, we had like three big players between Microsoft, Amazon, and Google, kind of dominating the public cloud space. Now, if you look at how the market is growing, the infrastructure, the overall global cloud spending itself is more than 100 billion market. So let's briefly look at how the market is. Now, we have so many players who are offering cloud services, and you have Amazon Web Services, which is kind of the dominant player with 33% roughly market share. So this is as of 2019. And then Microsoft Azure came along at 18%, and then Google Cloud at 8%. And one of the things about Microsoft was that it was Microsoft had a huge amount of tapped Windows customers, so the kind of captive customers for them, and it was easy for Microsoft to convince their customers to move from on-prem to cloud. So that's how Microsoft grew pretty fast. And then you have Google Cloud, and then IBM. There's IBM, and then there is Chinese company Alibaba, and then you also have Salesforce. Salesforce, although is not a huge player in terms of infrastructure, but it's still a huge SaaS player. And then you have Oracle, and then Tencent. Now, if you look at what's a good example of, we're talking about cloud. What is a good example of cloud? I mean, imagine you're now being able to participate in this Zoom session, okay? And Zoom is hosted by Amazon and then Oracle. So Amazon Web Services and Oracle together host the Zoom services. Now, imagine this is a perfect example of a software as a service application. Because what you did, you're not hosting anything on your machine. All you're doing is you're taking advantage of the internet, and then the servers are running somewhere in either AWS or Oracle. So that's a good example of software as a service, like Zoom call, for example. So this is all fine, but why would anybody want to move to cloud? Like all along, you have been, you have hosted your servers, your applications in a, every company used to have a network room where you had all these machines humming with a lot of noise, the cooling and everything. And then it was, it had always this board called restricted entrance. So not any employee could walk into your server room, right? If you recall those days, I mean, it was the case like 10, 15 years back. And then suddenly this cloud came along. And why would any company, any business, or even for that matter, move to the cloud? So one of the big things about cloud is services on demand. If you look at Amazon or even any of the providers, Amazon, for example, has more than 300 offerings. Everything from storage, networking, compute, Kubernetes, databases, Hadoop as a service, Spark, Splunk. I mean, anything that you can imagine is already available on cloud, Amazon or Azure or whatever. Okay, so if you want to, let's say, for example, you're at home, you are doing some compute intensive work. Now you're a scientist, okay? And do you go and buy a machine for yourself? You could do that. Or why don't you rent one virtually? Now that's where services on demand. It's not just machine. What if you want to run a Hadoop job, for example? Or if you want to run a Spark job. Okay, so you have all the services on demand. And they are easily accessible over the internet. Easy access and agility. Now, ease of access. So what does it take for you to access those services? All you need is an internet connection and a laptop, and that's it. You sign in, and then you can provision whatever you want. So it's like, it's like go to supermarket, pick up whatever you want, and bill it, and then walk away. It's that simple. So that's a beauty about cloud. Elasticity and auto scaling. So what is elasticity exactly? So imagine I have a cluster of machines, and now let's say take an example of Zoom, for example. Zoom doesn't have when it contracted with Amazon, it doesn't have that in I need 1,000 machines. What they would do typically is I need 200 of them, but then it should auto scale to 1,000. That's how you think. And as let's say in our session, we started out with 10 people, 20 and 50 people, but imagine there are like millions of Zoom sessions going on. How is, but imagine if the same Zoom kind of a thing is hosted on premises. Let's say Zoom office itself is hosting these machines, and it cannot have the kind of elasticity and auto scaling that it wants to, because as more number of users join, you need more resources, and then the cloud will automatically provide you these kind of resources on demand. You can pre-configure it, and then as more people join, as it becomes more compute intensive, and then another machine is launched, and then people will move to that machine, and it all happens seamlessly. And auto scaling is how you achieve elasticity. Now, when you set yourself for auto scaling, so your hardware infrastructure wraps up because on the demand, and then when the demand goes down, you kind of scale down back. Okay, so they are cheaper and better ROI. Now, cheaper is a relative thing. It depends in comparison to hosting your machines on-prem versus hosting it on the cloud. So you have better return on investment because you can manage your finances much better. You know how much it will cost you to host. But if you host it on-prem, there's huge amount of costs, fixed costs, and then you need personnel to maintain it. It's also, cloud is also highly secure. So what does it really mean, it is secure? Now, when you access your Zoom call, I think over the web, you must have seen that the call goes through HTTPS, which means that it is a secure URL. Besides, whatever data that cloud stores, right, it's always encrypted. So it's all encrypted at source. So even if your data on the cloud is stolen, I mean, whoever takes it can't do much with it. He cannot crack the data because by default everything is encrypted. Now, there are multiple ways you can encrypt. The customer or the user has a choice to encrypt the way the user would want, or allow the cloud provider to encrypt for you. Global network of resources. Now, remember when you said we talked about Zoom, and Zoom is a good example of software service. But most likely, depending upon where you are, in your case, let's say this call is hosted from India, okay, and it's very likely that Zoom servers are running in some region in India, for example, or in Asia. So most of the cloud providers, they have infrastructure across regions across the world. So they have in Africa, Europe, Asia, everywhere. Now the reason for this is because let's say if the call is initiated in India, and then if most of the users are in India, and then the infrastructure itself is hosted in India, so that you can work on reduced latency. You can also have a very good user experience. And having these cloud resources over every corner of the world, it's about being able to get these resources to as close as possible to the businesses. Easy backup and recovery. Pretty much every, backup kind of matters when you have a lot of storage services that needs to be maintained. And if you want me to take a backup, and it's easy to back up and then recover. High availability. So what does high availability mean, really? It's about the ability to, being the resources being available 24/7, which means the resources are available with no downtime and with no failure, which means you cannot expect a cloud service to be down. That's it. Remember the days when I think almost 10 years back, whenever we had to upgrade a mail server, what used to happen was the mail admin used to send us an email saying that the mail server won't be available from 10 a.m. to 12 p.m. kind of thing. And then and during that time, the mail servers won't be working. But that's not so in case of the cloud, because cloud is available 24/7. Now, when you move to cloud, what happens is, from the financial standpoint, most of your capital expense becomes operational expense. I mean, you don't have to spend as much capital expense. So what the benefit is that you can actually manage your costs well. You can predict your demand, and then therefore you can predict your operational expenses. That was not possible with CapEx. Okay. Now, okay, then challenges. Okay, so if cloud is so good, is everybody moving? Yes, a lot of businesses are moving to cloud. These days, in fact, even at the government level, a lot of services are now hosted in the cloud. But there are still some challenges, in the sense that there are still a few hiccups. Why businesses don't want to move to the cloud? One is security and privacy. For whatever reason, some companies still don't want to part with their data. They want the data to be on premises. Although cloud is a lot more secure than before, still some customers have hesitation in uh, keeping the data anywhere other than on premises. So they are very keen to keep the data on premises. And then other challenge could be very low latency requirements. Now, there's a different, although cloud provides very low latency, but sometimes if your application demands that it be available on-prem, because that's where most of our customers are, let's say in our office or whatever, in which case businesses may not want to move to the cloud. They want to keep their data on-prem and then run their applications on-prem. Government regulation. Now, there are some government regulations that make it mandatory for companies to keep their data on premises. Like for example, in Europe, or even Germany for that matter, all data pertaining to German citizens cannot be hosted outside of Germany. So in each case, if a cloud provider wants to uh, take care of German customers, then they may need to have a data center within Germany or similar to any other countries. So that's the kind of government regulation we're talking about. But if the cloud provider does not have a data center, then these companies have no option but to be on premises. Portability. So some of the applications or whatever they're developing may not be portable to cloud. It can be as simple as that, right? Other case, proprietary systems. Now you have a system that's completely proprietary to yourself, which means you design, you have your own language, maybe you have your own operating system and all that stuff. In which case, you stick to on-premises. But overall, the challenges are very minuscule, and the customers that may not want to move to cloud are very few and far in between. But in most cases, vast majority of customers are moving to cloud. Now, we talked briefly about the cloud service models, the SaaS, PaaS, and the infrastructure as a service. So software as a service. So what is software as a service? It's essentially like Gmail end users. And if you look at the diagram here, if you can see that you need infrastructure for everything. That's where infrastructure as a service comes, right? So when you think of infrastructure, it's primarily your RAM and CPU. And then on that, top of that, you have platform. This is a platform as a service. And then on top of that, you have SaaS. We'll go in depth into each of these in our next slide. Software as a service. Software as a service is a software licensing and delivery model in which software is licensed on a subscription basis and is centrally hosted. So what is a good example of SaaS? Your Gmail is a good example, or any application, your bank application, you're accessing your bank data over the web. That is software as a service. Or Zoom, for example, the Zoom call that we're taking, it's a software service. So this is mostly dealt with end users and consumers. But what happened behind the scene is, there is platform and then underneath there's infrastructure service, but you don't know anything about it. You don't care at all, right? So that's typically what software as a service is. Platform as a service. So what's a good example of platform as a service? So PaaS is a cloud computing model where a third-party provider delivers hardware and software tools to users over the internet. Mostly developers work in PaaS. So for example, what would be a typical example is like, okay, I need a database server. Okay, so I can buy a machine, I can set it up myself. Or instead, go to Google or go to AWS and then launch your maybe Oracle database, whatever it is, or MySQL. Launch it, and then you get an endpoint. That's the typical platform. Or maybe Hadoop service. Okay, so that's a good example of a platform. Now, what you see here, the logos, Elastic, Beanstalk, VMware, Twitter, Red Hat, OpenShift, they're all platform as a service. That's what they give you, a platform on which you can host your applications. The next is infrastructure as service. Now this is the bottommost layer. If you look back, go back 2 slides. So we're talking about the last bottommost one. Okay, that's infrastructure as service. Now that is when you think of infrastructure as service, it's primarily just two things. No, actually three things. One is CPU, RAM, and storage. Now, this is store is considered as a software-defined storage, but primarily when you think of infrastructure, what do you need? You need some storage, you need a CPU, and then you need some RAM. That's all you need. So that is on which you have platforms, and then on top of platforms, you have your applications running. So this is infrastructure service. Is a cloud computing service where enterprises rent or lease servers for compute network storage in the cloud. Network or IT admins manage the resources. If you remember, a decade or so back, when you had no cloud, who was doing this infrastructure management? Your IT guys. So you ask them, you're a new employee, you join, and then they'll give you a laptop, right? Or you ask for, no, I need a Linux machine, and then they will come and then install it and set it up for you. So that's precisely what infrastructure as service means. So when you think of service, it's like the ability to provision these on demand. This kind of infrastructure is infrastructure service. So cloud is all fine and good, but what happened that companies are now moving to cloud, and what exactly facilitated cloud? So what technologies helped cloud to grow? Because the technologies used in cloud, I mean, they're not the same things that you're using on premises. I mean, nobody had a hypervisor kind of thing on premises. So let's talk about what are the technologies that that facilitated cloud. One of the biggest thing is virtualization. Now remember, I was talking briefly that VMware was one of the big pioneers about virtualization. In fact, a lot of companies did, but I think people remember VMware very well. So VMware did it. So it's all started from VMware, and then other companies took over. So what's exactly is virtualization? Now there are different types of virtualization. Remember when you're talking about infrastructure, compute, CPU, right? The first step is the compute virtualization, which is called hypervisors. So if you look at the diagram towards your right, we have a piece of hardware. So primarily our interest is a CPU or RAM, and then you have operating system on top of that, and there you have this virtualization layer, which we call as hypervisor. Now with the hypervisor on, you can now have 3 or 4 virtual machines, which you can actually rent out. Remember, we had previously one machine and one person was using it, or one company was using it. Now the same machine, now you install hypervisor and you virtualize it. You can have 3 or 4 computers on top of that, and then different businesses can own each virtual machine. So one guest OS can be owned by one company, and you can rent it out. Okay, so that's called virtualization. Now that is very important piece in cloud. So there is no cloud without virtualization. And then the next thing, storage virtualization. So same thing as what we described about for compute happening to storage, which means you can have a huge amount of storage, raw storage, then install storage virtualization on top of that. Then can you divide that into blocks and then rent those pieces of blocks for various companies. So that is being now possible thanks to virtualization. Now, one of the big things that about virtualization is that it enabled multi-tenancy. So what is multi-tenancy? So multi-tenancy is like same computer being used by several people, and they don't know about each other. They don't know that there is somebody else using it, because when a tenant gets a guest operating system, he thinks he owns the computer, although there are other guest OSs already being hosted on that. So that's a good enabler because we are now able to maximize the utilization of the piece of hardware, and that's how companies make money, because typically 20% of the time hardware is utilized. Now with virtualization and all that, it is utilized 100% by different people, and then you can make money out of it. Now the other thing that also facilitated is networking. So even networking got virtualized. So what we call as software defined networking. You think about virtual switch, virtual routers. Okay. Now before the software defined networking, if you have to, you may need one switch that you could kind of give it, use it for like 5 or 6 customers. But now with virtualization, that range goes up huge. You can more than a couple of dozen customers can walk. You can create virtual networks out of just one physical switch. That's the beauty about virtualization here. And then after this VM virtual machines have been there for more than 10 to 15, more than 15 years. And then in the last couple of years, containers and Kubernetes came along. Now, what did these containers do? Now, these containers Kubernetes have made are now able to extract even more juice out of the same hardware. Now, in the same hardware, as we have seen, you can have 3 or 4 guest operating systems or 3 virtual machines, but you can host maybe 1,000 containers, assuming you containerize your application. Now, we'll talk about that in detail, what containers can do and what they have done, and then we'll talk about container Kubernetes in detail a bit later. But these are the technologies that facilitated cloud. So without virtualization, there's no cloud, right? Now, the new thing that's coming up, containerization. And then now we also keep hearing about cloud native. So what exactly is cloud native? So it's about, cloud native is all about containers, and then being able to make your application so portable across clouds, public, private, or across any private cloud. So that's all about being cloud native. Cloud native is all about moving around your applications across various different cloud providers. So we talked briefly about virtualization. So traditional architecture, if you look at, you have this hardware, your operating system, and applications, and then now it's moving more towards a virtualization layer. So which means now you can actually extract more out of this hardware. You can host more applications, and all of them in isolation to one another. So this is about being able to maximizing the utilization of your hardware. So how are you doing with the time? Is it ready for the first section of the QA, or will we wait a little bit more?
So after 1 hour, is it okay to take the, like around 10:30 Indian time?
So yeah. Another 10-15 minutes? That's fine.
Yes.
Okay. So let's talk briefly about containers. Now, containers have been around maybe 5 to 6 years, although the technologies have been in some form or the other for the last 7 or 8 years or longer. Now, what are containers? And you keep hearing about it all the time. So containers are lightweight, isolated operating system processes running on a host. Now, here is where you need to differentiate. But unlike virtual machines, containers does not need a hypervisor. Now, although some virtualization layer is needed, it doesn't need a hypervisor. Now, the drawback is that all containers on the node share the same OS. Now, remember, if you talk about virtual machine, you have this virtualization layer, and you could have a Windows machine and a Linux machine sitting on that. But then when you come to containers, right, it's all the share the same operating system. So, which means containers are processes. They have their own life of their own, but yet share the kernel of the same operating system. Now, remember I said it does not need a hypervisor. It's not exactly completely true, but what happened was that over a period, a lot of technologies came along. Some section of the hypervisor got merged into the operating system. Like, for example, hypervisor facilitates isolation. okay, and being able to transfer calls from the operating system to the hardware and then back. Now, when you come to containers, they're essentially processes. They have strong isolation, and they use these isolation features called control groups, namespaces, and network namespaces. So control groups will make sure that you as a container don't use more than this much of CPU or this much of RAM. And they also live in the namespace. So namespace is an isolated chamber. So which means if you don't know, if you, so processes, containers in the same namespace don't know about the containers, other namespaces. And this is very important, you see, because at some point you may want to have multi-tenancy, right? So which means containers from across two companies are actually running on the same host and they don't know each other, which is what we want. So containers with C groups and names will help you provide that. So on a comparing on a one-to-one basis, uh, containers compared to virtual machines, they come up very fast in a matter of seconds. Now it may take like 10 minutes for you to bring up a virtual machine, and it takes less than 30 seconds for a container to come up. So that's how fast it is. And they're extremely lightweight. Now, Kubernetes. When you talk about Kubernetes, why would you need Kubernetes? Because now, let's say your application, uh, now we all know about containerization. I mean, containerization itself is a huge subject in itself. You can't do any justice in like 10 to 15 minutes of talk. But think that all applications, pretty much any application that is being developed, will move to containers pretty soon. There's no escape because you want so many nice, wonderful things that containers and Kubernetes provides. I mean, you cannot lag behind. So every business, they want to transfer their application to containers. Now, containers are fine so far. They run fast, they come up fast, they're lightweight. But then, as your application grows big, you'll have hundreds of containers. Now you need a mechanism to orchestrate or manage these containers. So that's where Kubernetes came along. So Kubernetes started off as a project in Google, and Google has been using containers and Kubernetes for a long time. And then Google decided to make this public project. And then in 2015-16 time frame, Google open sourced Kubernetes, and then Kubernetes took off. Now there are other products in the cloud space similar to Kubernetes, like Mesos, but Kubernetes is the dominant platform, pretty much, to host container management system. So what Kubernetes does, it's essentially Kubernetes is an open source container orchestration from Google. Kubernetes automates computer application deployment, scaling, and management. So pretty much what you are doing about managing, deploying your application, a lot of it is automated. So remember, we're talking about testing the application and then moving into production, and then there's a huge lag in between testing, staging, and deployment and production. Now with Kubernetes and containers, you have simplified it into a matter of minutes. So all you need is to test it, and then the kind of situation that you see, it works in testing environment, it doesn't work in production, all that is gone, because it's about consistency, being same image, and containers and Kubernetes facilitate that. Okay, now it's highly agile and extensible. Now the very big thing, which is my favorite, is desired state versus current state. So what does it really mean? So when I have an application, right, I tell Kubernetes, this is what I want, and then you figure out how you provide this. Now imagine that's a huge compelling reason for a lot of companies to move out. Like for example, I say I need 10 containers for this application to be running. Now Kubernetes will ensure that 10 containers are running. Okay, so what does it mean? What if one of the containers go to an error state? Automatically Kubernetes will bring out another container and then configure it, put it to the network, and then this happens without loss of functionality, which means all the routing and all that thing Kubernetes will automatically take care, so that no user will lose any connection. Okay. Now, horizontal and vertical scalability. So what this means is that uh, if container demands more resources, Kubernetes will provide that. If container demands no extra nodes to launch more containers, Kubernetes will provide that. So that's about being able to horizontally and vertically scale your applications, and that gives you a whole lot of flexibility for developers to use something like Kubernetes. And then rolling updates with zero downtime. This happens with the same existing infrastructure. If you remember 10 years back, if you have to update a software, then you have to bring a secondary system and then install your version v2 there, and then use your load, and then you funnel your load balance into the next one once it is ready. So you need to have this duplicate infrastructure going around. Not anymore. It's rolling updates and with absolute zero runtime. So containers, one after the other, they change, they die, and then the new one comes up, all matter of seconds, and then you have new application in a very quick short amount of time. Automatic upgrades. It's automatically your versions will upgrade as you tell it. Reduced OpEx and infrastructure. So what containers and Kubernetes bring you is like they want to extract more juice out of the same infrastructure, and that's why they are so popular. So in the cloud, predominantly, take any public cloud, Kubernetes and container is a predominant usage across all cloud platforms. So we talked about the various types of cloud that's out there. Public cloud is like Amazon, AWS, or Microsoft Azure. So public cloud is a multi-tenant platform. So you remember this thing, it has to be a multi-tenant that uses standard cloud computing model to make resources such as VMs, applications, or storage available to users remotely. Public cloud services may be free or offered through a variety of subscription or on-demand pricing. So this is a very common type of cloud. Now, private cloud. What is private cloud? So private cloud is a computing model that offers a proprietary environment dedicated to a single business entity or a set of dedicated users. And this is not for public. For example, if one of you want to become an entrepreneur and set up a private cloud, what would you do? I mean, think something like OpenStack is a good example of it. You can use OpenStack and then set up your own private cloud. So a lot of big companies, although they use public cloud, they also have a private cloud within themselves. Now, these days, I remember, when a new employee joins, he gets a laptop and a virtual machine on Amazon, or that virtual machine can be provisioned with a resource in-house, which is what a private cloud is. Hybrid cloud. Now, essentially, hybrid cloud means a mix of public and private. But then the thing is, when you think of hybrid, it's about being able to move resources from private to public. Okay, so you as a business entity, you may have a private cloud, and then you may have a public cloud. You may use public cloud. But then if you don't connect with the two, then it's not exactly a hybrid. So hybrid cloud essentially means being able to have both private and public, and being able to provide a private network to connect these two resources. Now, Google Anthos is a very well-known hybrid cloud platform, and so is Red Hat Advanced Cluster Management. Now, let's look at the top cloud providers that we actually saw before. The AWS, Salesforce, Rackspace, these are familiar names. And then we'll briefly talk about Amazon AWS. It's by far the largest cloud provider, and it provides plenty of services. And it has very high penetration in the market. It has over 45 billion annual revenues, and pretty much everything that you need as you expect from a public cloud is available in AWS. And you have Microsoft Azure. Microsoft Azure is the second largest cloud provider, and it essentially capitalized on businesses with Windows installation and very fast growth. And we'll talk about GCP. And then why don't we take a break and then look at the questions? Let's open up for
we have just two questions, Ram. Like better you take a break for 5 minutes and you can join.
Well, actually, I don't need any break, but there are only two questions.
Yeah, I think our InterSkill admin will share the Word document with the questions. Whitson, are you ready? Can I just copy them?
Yes.
Yeah. Please share the questions so that Ram can answer.
You can read the questions and then I will answer.
Yes. Sure.
Okay. The first question is, do we use cloud services in smartphone?
Okay. So smartphone, what you have, let's say take example of a smartphone, right? There's an app running. So the whatever is running is only app that runs on your phone, but then the app is communicating to some service, right? It's communicating to some infrastructure, and that infrastructure is in the cloud. Now Zoom, we talked about Zoom before, so you can access from the laptop, right? So you have the Zoom app that runs. Now what it does is it's a very thin app. What it knows about yourself, who you are, from where you're logging, but then there is all the services are running in the cloud, as you say, AWS or Oracle in case of Zoom. So the backend infrastructure is still on the cloud, whether it is cell phone or your computer. Now, the only difference is that the API will be a bit more customized for mobile applications. That's all there is to it.
Okay. Is cloud simply a storage center? The second question.
No, we will actually look at, okay, so when Amazon came around first time offered cloud, it offered only storage. Now, there are some cloud providers are exclusively storage, like for example, box.net, right? And even Azure has its own storage, but cloud is a lot more than storage. In fact, the storage services are less than 1 or 2%. Predominantly, cloud provides infrastructure, like compute infrastructure, network infrastructure, pretty much everything. We'll go through GCP, Google platform, and then I'll walk you through what all Google provides, and then you can see what. And it's the same thing, whether it is Amazon or anything. There's plenty of services, not just storage.
Yeah, the third question, for someone learning and starting to work on cloud, would it be advisable to focus learning only one particular cloud service provider or multiple to have a better idea of the overall providers?
Okay, so remember we talked about what facilitated cloud, which is virtualization. All these clouds have use virtualized services. Now, if you think about between, let's say Kubernetes, for example, right? Kubernetes, it's called by different name, but it's the same thing, whether it is Google, AWS, or Amazon. So you learn one cloud. Let's say you learn Amazon. It will be very easy for you to transfer your skills to Azure or Google, because the underlying infrastructure is all very similar, because they offer similar technologies. Now imagine if they really want to grow, they can't make it anything proprietary, right? Because remember, the portability is one big thing that every businesses would want. Portability of the application is very important. So although they may call by different names, but it's all underneath similar infrastructure. Like data, you have databases, they have virtual machines, they have virtualization layers, everything. It's except that they have different names. Now, that is for the most part, but a cloud provider will provide some competitive advantage, right? So, for example, the kind of services that Google provides for AI and machine learning, AWS doesn't provide those. So there are some subtle differences, but to answer your question, these skills can be transferred. For the most part, they are transferable from one to the other.
Okay, brother. The fourth question is, I want to know how to perform cloud analytics.
Okay, cloud analytics. Okay, when you think of analytics, we will actually look at something called Google BigQuery. There's a tool called Google BigQuery. Now, there is a similar tool like that in AWS and then Microsoft Azure. So that's a tool that you use to do cloud analytics. So when you do cloud analytics, right, you procure the data, you run some machine learning or even query engine on top of it, and get some insight into it. Insight is the kind of intelligence that you want to be able to present to your customer or user, right? A competitive kind of information. So on GCP platform, you have something called Google BigQuery, which is a Google Cloud Analytics tool. And using the tool, you can do analytics, cloud analytics.
Yeah, the next question, good tutorials for orchestration.
What is that?
Good tutorials for orchestration.
So I'm guessing when you said orchestration, is it container orchestration, which is Kubernetes? I don't know what orchestration is it talking about. I'm thinking it's container orchestration because I think that's the only thing that I referred in my presentation. So essentially it's Kubernetes. So there are a bunch of tutorials on Kubernetes. If you go to kubernetes.io, this whole tutorials available. You can learn. Or so one of the goals of this presentation is kind of gauge what the user interest is, like the interest from participants, and then see if we can offer a course that meets your requirements. So as part of InterSkill team, we are planning a course on Google Cloud technologies, and we will cover some of those Kubernetes concept in that course. You'll get more details at the end of the event. You'll get an email.
Yeah, the next question, can we directly learn Kubernetes instead of Docker and then Kubernetes?
Okay. Now, there are different things. So first of all, people get confused about what Docker is. Remember, I did not mention Docker anywhere because Docker is kind of dying away. Now, why I'm saying, I mean, Docker as a container engine will continue to exist. So if you want to learn Kubernetes, you have to start with containers. But then if you want to understand containers, then you have to understand virtualization. If you want to understand virtualization, you have to learn hypervisors. Okay, so you cannot jump in and try to, there are some long distance buses that if you get in between, you won't get a seat. So if you want to, you can learn containers straight away. But then, okay, why do we? So for everything, there should be something like why. Why am I doing this? Why do I need containers? And then you have to step back and then hypervisor. So why hypervisors? Then you have to come back again. Okay, virtual machines. So let's, if you want to simplify this, then start with containers, and then Docker. When you start with containers, you'll anyway learn about Docker, and then you move into Kubernetes. Because Kubernetes, I mean, without containers, there's no Kubernetes. All right. Does that answer your question?
Yes.
Yeah, and anyway, so we will, depending upon your questions and then your inquiries, we can tailor courses that meet your needs. And we may be offering a course on containers and Kubernetes. Yeah, you can go to the next question.
The next question, I work as a backup admin. Now, what is backup admin perspective as it's automated in cloud?
Okay, I don't know what that backup admin really means. Is he an IT backup? I don't know, like backend or backup? I don't know what it is. So let's say the question is about backup and recovery kind of a thing. I'm guessing it's about storage, or or maybe that IT professional is a back-end engineer working on server side technologies. But if you remember, back in the days, uh, 10, 15 years back, there were plenty of system administrators. Now, in my company, there are hardly any system administrators because they're all gone. I mean, nobody hires system administrators these days. No Unix administrators. In fact, even we don't even have DBS anymore because everything has moved to the cloud. And when everything moved to the cloud, it's all about self-service. You know, when I first came to US, if I had to needed a Unix machine, I need to put a request to the IT. They'll provision you one. That's not the case anymore. They give you access to the cloud, and you whatever you want, you create it there. It's the database, virtual machine, Linux machine, Windows, anything. You're on your own. So that's what cloud has enabled, being able to self-serve, and that's a big thing when things move into cloud.
The next question, is it needed to learn cloud for cyber security?
Cybersecurity is a completely different thing. Although you should know something about cloud. In fact, when you think about cyber, it's all cloud, right? And the cyber security actually became popular only because of cloud technologies. Because if you're hosted on-prem, you have less of a need for the security technologies. But how much depth? I'm not aware of how much depth you need to know to be about cloud security. I'm not that familiar with cloud security.
Yeah,
but
we're going to have one more session on cyber security on 10th of October. Please sign up for that, where we will understand cyber security, what is needed, and the connection between cloud. Okay. Okay.
Yeah. So that said, it's anything these days, it has to be cloud centric. But it doesn't mean that you must know be well versed with cloud technologies. But if you're an engineer and eventually you will want to get your feet wet, you better get familiar with cloud technologies.
Yeah, the next question. I learned WBI tool how to place database on cloud and connect WBI tool to cloud and fetches the data on how to make cloud analytics.
Okay, so Tableau is kind of a proprietary tool. Okay, so when you think about all these cloud technologies, most of them thrive on open source technologies. Hadoop, Linux operating system, and then some proprietary stuff pertaining to the cloud. So I don't know particularly about Tableau, but in Google there is something called BigQuery. We will touch upon this BigQuery, which is actually your analytical tool. But see, when you think of cloud, right, it's about huge scale, unprecedented scale. We're not talking about terabytes. We're talking about petabytes. Now, I don't think Tableau handles petabytes of data. I don't even think Tableau handles terabytes of data. But nobody would want to go to cloud and do Tableau. Okay, because Tableau is for a very small scale, but think about your data being terabytes and petabytes. That's when will cloud come into being. Although if you have, you can still use BigQuery for smaller data. Nobody is stopping you from doing that. But in which case you have to export your Tableau data into some form which BigQuery can understand. There may be tools available, and then let BigQuery handle the rest for you.
As
Next
of now,
question,
these are the questions.
You're done with questions?
One more question.
Yeah.
To have an overall grasp, should someone focus on both cloud DevOps as well as infrastructure solutions? or pick just one?
Okay. So can you repeat the question again? It's a kind of a bit vague.
Yeah, to have an overall grasp, should someone
Mhm.
focus on both cloud DevOps as well as infrastructure solutions?
Okay. That depends on your interest. So what I would suggest is, right, it's never the case that I'll do this and not that kind of thing. I think if you're here in the cloud, you're here for the long run. Okay, I would expect that you'll be working for the next 20-30 years, right? I mean, assuming most of you are just started your career, I would expect that you would last 20-30 years. So instead of focusing on just DevOps or whatever, right, focus on building the fundamentals of the cloud. So the stuff that I have been covering, right, and then which I'm going to cover in the next few more slides, you cover get a holistic view of everything, and then build expertise in maybe DevOps or machine learning or whatever. Pick up 2 or 3 of them and then build on it. Now I'll tell you why this is important, because sooner or later you think you have to come back and learn this stuff. Okay, you're now into DevOps, and then soon you have to learn something else like infrastructure, right? And then you don't come back and learn some of this stuff. So build the foundation strong, and then build the expertise on top of it. Okay, does that answer? Okay, any more questions?
Yes. Yeah, we'll take more questions in the end.
No, if there are any, we can wrap them up now. No big deal.
Uh,
Right now, we don't have anything, Ram.
Okay.
We have answered all
Okay,
questions.
let's move forward then. Okay. Okay. Now today, so we covered some amount of cloud technology. What we're going to do now is we'll take a peek into GCP. Now, why GCP? Because it is my personal interest. Some other person may want to dwell on Amazon Web Services or Microsoft Azure. I'm a certified GCP architect, and I love GCP products because, in my own opinion, GCP products are much superior in any way to Amazon or Azure. And GCP is actually the fastest growing among the big cloud providers. So GCP is a platform, is a suite of cloud computing services that runs on the same infrastructure that Google uses internally for its end user products, such as Google Search and YouTube. So the GCP products that are being offered for public, they're the same thing that Google uses internally. So which means it comes solidly tested. So apart from the management tools, Google GCP provides a modular cloud services, including computing, data storage, data analytics, and machine learning. So why am I pitching GCP? So GCP, though a late entrant, made steady, fast progress in the cloud technology space. And GCP is based on the same technologies Google uses internally. Google is in the forefront of innovation in cloud technologies. In fact, a lot of innovation in Google, right? It came out of, in cloud technologies. It came out of Google. Example: Kubernetes and container orchestration. Google got the earliest implementation of SDN in the cloud. So Google's network infrastructure is by far the superior to any other, not Azure, not AWS. It's way ahead. And once you go into details, you will know why that is. And Google Cloud platforms are available just about every continent, everywhere. They have regions, they have zones. So if you look at the Google Cloud Network map, and then these points of presence, and these are Google's dedicated pipelines, which means Google laid out undersea pipelines for its own network services. So they have not rented it, they have not borrowed, they have their own pipes under the sea. So you can imagine the kind of networks that Google has. So on this aspect, why I'm encouraging people to learn GCP, because we talked about why GCP is superior to other services, cloud services. Now, demand for cloud infrastructure services is exploding, and Google will pick up a good slice of that market. Okay, so which means if you're well versed in GCP, right, you will have much better chance of landing up a job. There are a lot of companies wanting to move to cloud. Huge employment potential for GCP skills. Now, there was a recent survey that said that GCP certifications are the #1 choice of certifications. No, not PMP, not Amazon, everything. Google services are the #1. It's the highest salary-wise potential for GCP skills. And there's also a huge demand for professionals with GCP certifications. And GCP is expanding. It's adding more services, expanding into more markets. So what kind of products are available? So you have compute engine, Kubernetes engine, app engine, cloud functions. Now we will touch upon each of these briefly. And one of the big things that Google has in terms of its products and services way beyond, I mean, like big data, for example, right, or machine learning. There are a huge amount of state-of-the-art technologies that nobody has. So Google Compute. So what Google Compute lets you? Google Compute Engine lets you create and run virtual machines on Google infrastructure. If you remember, we talked about renting a virtual machine. That's what Google Compute does. It offers scale, performance, and value that allows you to launch large compute clusters on Google infrastructure. It's not just one machine. I want 10 machines. Right? It takes minutes for you to provision. So there are no upfront investments. You can run thousands of virtual CPUs on a system that has been designed to be fast, and it provides consistency of performance. So you have high performance scalable VMs versus infrastructure as a service. So you have industry leading price and performance. And GCP also gives you low cost automatic discounts. So the one thing I found very interesting with Google Cloud is, now you rent a machine, right? After 1 month, that same machine is now discounted. So then they'll proactively give you that discount. Okay, so you don't have to ask them, you know, you offered the discount, so give me the discount. It's automatically adjusted. Fast and efficient network. Predefined custom machine types for both Windows and Linux. Now, if this is confusing to you, don't worry, because I will go and show you how this is. We'll go to Google Cloud website, and then we will show you all this stuff. Now, the other things that are being offered, App Engine, which is predominantly platform as service. And this is where you just take your code and everything else is handled. You don't have to ask for database. You don't have to ask for anything. Everything is handled internally. Compute Engine, Kubernetes, container orchestration, cloud functions, microservices, and Cloud Run. You must have heard about something called serverless. It is getting very, very common these days. That's a new thing. Companies want to go serverless and then design their applications so that they will spend even less on cloud. It's getting cheap, you know. Google Cloud Storage is highly performant, used to store unstructured data like videos, images, archives. It's based on Google's proprietary system. It's accessible through GSUtil. It's very fast. It can scale to petabytes. We're not talking about terabytes, we're talking petabytes. It's very similar to AWS S3 buckets. It also has SSD and block storage. Now, GCP databases. Okay, this is one thing that Google offers. So, the cheapest one is called the Cloud SQL. It's an RDBMS. Offerings include managed MySQL and PostgreSQL. Data is stored in the same region. So if you have a small database, MySQL based, running up terabytes, then Cloud SQL is your option. Now there's anything called Cloud Spanner. Again, this is Google's proprietary. It's a relational database. It's a very high QPS and very low latency, fully managed, mission critical. So on high ACID properties, which is atomicity, consistency, and all that. Google proprietary. It's relational, structured, and semi-structured data. Now, when you're talking about petabytes, this is what you will need. And then again, you also have Google Cloud Data Store, which is a highly scalable NoSQL document database. Now, remember we had this RDBMS for a long time, and now RDBMS is going more towards NoSQL document kind of a database. So that's where data store fits in. Again, it has got strong on ACID like transactions. And then you have like Google Cloud Big Table. Now imagine you have database with 1 million records and then 1 million columns. I don't think Oracle would be able to handle that. But the way now it's all database is being designed is like you could have unstructured, semi-structured data sitting in database in a wide column database service. It's called the Google Big Table is for that. It's a NoSQL wide column database similar to Hadoop's HBase. A sparsely populated table that can scale to billions of rows and columns. Needs servers and clusters, of course. And then GCP BigQuery. So BigQuery is one of this analytical platform. So the way it happens is you have your data, you can store the data in one of your storage devices and then let BigQuery process your data. So one of you asked about Tableau. Now Tableau, the kind of stuff that Tableau does, it's a very, very small job for BigQuery. And it's for, so data warehouse service is really fast and really price competitive. It's cloud-based, serverless. So what does serverless mean? So typically, when you're doing any job, right, you tell beforehand, I want X number of servers. Like for example, Kubernetes, when you're creating a Kubernetes cluster, I have to start with, okay, I need 5 nodes of Kubernetes, okay? But BigQuery is not like that. It depends, it will figure out how much data needs to be processed and it will automatically provide that many number of servers, okay? And you pay by query, not by data. In fact, the way you pay for this is like amount of data processed and returned. Okay, so let's what we'll do now is so those of you who want to experiment with GCP, right, you can actually go to cloud.google.com and sign up using your credentials. Now you have to follow the instructions, and what happens is every user gets a $300 credit, and it's valid for 1 year. And with the $300 credit, you can create whatever resource. It's like a buffet. Yeah, you can eat whatever you want for 1 year, kind of a thing. And but you need a credit card number that won't be used until the expiry of your credit. So those of you who are interested, I encourage you to sign up and play. Accessing GCP services. So how do you access GCP services? Now I'll show you one way, and then there are several ways. You can access from the user interface. Go to console.cloud.google.com, which I'm going to show you right now in the next few slides. We'll go there, or you can use gcloud command utility, which is essentially Google SDK, which you install locally on your computer, run through some setup, and then you can access Google Cloud services from within your laptop. So that's what I was talking about. It's called Google Cloud GCP. Okay, So the other thing I wanted to encourage is, Google certificates are very valuable, and Interskill will help you uh, achieve some of these certifications if you join one of our course program that is coming up. So what are the certifications? We have like associate cloud engineer, cloud architect, cloud developer, data engineer, DevOps engineer. And then there's a new thing that came up recently. It's called Google called professional machine learning AI engineer. Now this DevOps and data engineers are in huge demand, and so is cloud architect. Cloud architect is for somebody who has uh, enough cloud experience, but for those with engineers with couple of cloud years of experience as an engineer, you should attempt data engineer or DevOps engineer. And Interskill will help you achieve your certifications. So what we'll do is now we'll go through. I'll walk you through the console. Let me move this here. So go to console.cloud. So the services that are offered are humongous. Okay, I can only cover only some point of it, but we will see how much we can cover. So typically, this is how you get it. I kind of signed up. I signed up a long time back, but this is how you'll. But if you're a new user, right, what will happen is it will show you how much credit you have. So every one of you, every new user will get $300 credit, and you can do whatever you can consume it. Okay, so this is home, and this pops up. So what is this pops up? Now remember, when you talk about distributed services, so most of your services are distributed, and these services are, if you are familiar with the services oriented architecture, all services communicate. So they communicate using a pub sub model, publish subscribe. This is a model as for asynchronous communication between services. So you'll be able to provision topics and subscriptions from here. Okay, now this is Google Marketplace. What do you get in Marketplace, right? Remember, we go to your Raitu Bazaar in Hyderabad, right? What do you get? Pretty much everything, right? So if you want to deploy anything, search for, let's say you want to deploy Oracle on cloud. Search for Oracle RDBMS. Okay, now you get plenty of. Okay, let's search Oracle database. Okay, so you get a bunch of Oracle stuff that you can host. Okay, you can build up. Okay, so that is your marketplace. Now let's see what are this billing. So obviously when you're consuming resources, you'll see billing, APIs and services. Now we come to the one that is actually of interest. So App Engine, right? Remember we talked about App Engine. Essentially, you bring your application. That's it, and you don't have to. So if your application runs on Python, you just select whatever you need, and then what kind of environment, standard or flexible, and that's about it. You can go next, and then basically load your application there and then run it, and then it scales automatically. You don't have to worry about whether there's enough resources or not. So it's all automatically done. Okay, now let's go to Compute Engine. Remember we talked about virtual machine. Okay, so how do you create a virtual machine? Okay, create here. Give it a name, give it a label. See, region. Remember, let's say you're in India. See, you may have an option for a site close by. There may be Hong Kong, Sydney, Singapore, wherever, Mumbai. There's Mumbai too. So you have an option to host a machine closer to your place where you live, right? And then let's say a region you choose Mumbai, and then there has a zone. Zones are like kind of data centers, and then you have multi-purpose or memory optimized, and choose how much of RAM you want, and then how much of CPU, and then well, what else? That's it. So you create it, and then it'll take a couple of minutes, and then you'll get a virtual machine. Similarly, you can also create virtual machine template from a machine image, or you can pick up from the marketplace. Okay, so that's about creating a virtual machine, and you can also create a cluster out of this. See, instance groups. Okay, so you can create a bunch of machines together at the same time, and then sole tenant nodes. So these are like, if I want one physical node to be given to me exclusively to myself, okay, I don't want to share. Let's say, for example, I want a situation where I don't want to share this node with anybody else, right? Then this is the option you choose. And then you have a TPUs. So TPUs are what do you call? It's called tensor processing units. It's very similar to NVIDIA GPUs. Now you can have machines with TPUs or GPUs. So this machines with GPU and TPU will help you run your machine learning or AI based workloads. Okay, so that's the thing. So let's go and see what else we have on offer here. Okay, so we covered, and then Kubernetes engine. Okay, so Kubernetes clusters. So this is the most widely used, not only in GCP, but it is the most, Kubernetes is the one that is very widely used even in Amazon and Azure. Okay, so you have cluster, and then you can have like zonal cluster or regional cluster, and then depending upon how your you can choose what version you want. It's 18 is actually the latest, but no, I think they have 17 here, and then you can choose zonal or regional, and then let's go to create and see whether it creates. Okay, now it's going to create. It takes some time to create a cluster. So you can also have you can also make the settings for it. You can change the settings depending upon how you want it. Okay, and so it's right now it's creating a cluster. Let's see how it's creating. Okay, so let's go back and then see what else we have. So this cloud functions and the cloud run. So remember I talked about serverless. Serverless is the ability. So when you're running your applications, you don't say I need 3 machines or 4 machines. All you need is that it's kind of an event-driven application form where a container is launched when there's a request, and when there are no requests, container will just not be there. It will just sleep. Now you have VMware engine. So this is probably what Google Cloud Anthos is. Remember we talked about hybrid cloud. So this will help you move your infrastructure back and forth between VMware and Google Cloud. Okay, it takes a while to come up. Okay, it may take some time. So let's go back. Okay, I have to enable it. So yeah, so we can enable it. So normally by default, all the APIs are disabled. So the way Google infrastructure work is that you need to give permission to each service to act each other services. Okay, so normally they're by default they're disabled and turned off, and you can enable them later. It's all about creating a secure services across. Okay, so what else we have here? We have storage. Remember Bigtable? We talked about Bigtable. It's a database. You can create an instance and see how big of an instance you want. SSD, HDD. You know what SSD is like? Very high, very fast storage. And you select a region. You select how many nodes you want, and then that's it. Okay. Let's go back. No, I'm not turning on anything on because it will cost me. I have to turn it off later. Okay. Let's go back to again cloud.platform. Okay, and then you have data store, which is again a database, and then you have memory store, spanner, which is remember we talked about spanner. It's another database. So these are all storage stuff, and then you have networking. Remember, Google has some of the biggest networking infrastructure. Now, if you look at VPC networks, so whenever you something that we did not see when we're creating a virtual machine. So when you're creating a virtual machine, that machine has to exist in some network. Okay, so typically Google creates one default network for you, and then you put all your machines in the network. Now, one beautiful thing about Google is that they have done the most beautiful job in implementing software-defined networking. So you have a machine in US Central one, and you have another machine in Asia North, right? They can communicate together over private IPs, which means it doesn't traverse the public internet. Okay, this across regions. But remember, that's not the case with Amazon. With Amazon, if you have an instance so far apart, you have to traverse through the public IP address. For that, again, you have to pay for it. Now, why Google has been, because Google invested on this software-defined networking technologies, that it has been able to do that. Okay, and then so you have VPC peer networking. If you have like now, if you see that I put everything under project. So if you have to resources in one project, don't see resources in other project. Okay, so if you want to move across, then you have to use shared VPC, and then again if you have to communicate with another tenant, you can use a network peering and so on and so forth. Okay, so let's go back to what else we have here. Okay, let me go to console dot. Okay. And why is it slow today? Okay, so where are we now? Let's come back here. So we saw storage. Okay, and then monitoring. Remember, every application needs some kind of monitoring. So if your application runs into an error or an error state, how do you debug it? Or you have to find out where the error is. So there are a bunch of tools. There's a debugger that will actually precisely tell you where your application is failing. Okay, and there's an error reporting and the profile. So all these tools can be used. Okay, and then you have cloud build, cloud task, container registry. So the way when you think about Kubernetes and containers, remember we said, it works on my environment but doesn't work in other environment. That's a problem that we always had. Okay, now all those are gone completely when you think about containers and Kubernetes, because containers and Kubernetes are about portability, which means the same thing will work everywhere consistently. And how do you achieve that is like whenever your container image is ready, you push it to container registry, and then everybody else picks it up from the registry. So that's what that is. Deployment manager, if you want to, how do you deploy resources? Now, remember we created a Kubernetes cluster by clicking some mouse clicks and all that. But in real life, that's not how it happens. In real life, what you'll be doing is you'll be writing G-Cloud commands and then making use of a deployment manager to deploy your infrastructure. When I say infrastructure, it's not one or two machines, right? It's about 20 different machines in 2 different networks with different routes and different IP tables and to manage the routing and all that. So it's all how you this how you build using deployment manager. Okay, and source repositories, it's like our GitHub. Okay, and then big data, you have Composer, you have Dataproc. You have Dataproc, it's very similar to Hadoop. And then you have Dataflow, and the difference is that it supports online real-time streaming. And you have IoT. You have BigQuery. BigQuery is the one that will help you with what was that, analytics, right? And yeah, and what else? So you have again. So the one thing that differentiates GCP, Google Cloud Platform, from other cloud providers is that it has got a huge amount of AI platform tools that that other the other providers don't have. Abundant of thing. You also have Jupyter notebooks. There's a whole lot of vast things. And then you also have partner solutions. It's like, you know, you have a Redis database. You can use Redis. You can come here and then launch any of those partner solutions that you have. So, so that's the crux of what we have on the GCP. And there's also billing and support, IAM and admin. Essentially, it's like when you, let's say you're the admin of GCP, right? What you do is you create a domain and a project for your company or for a business unit, and it resides in some kind of a domain. And from here on, you kind of give permissions to various users. Like, for example, some users can only create or it can only look at a virtual machine. They cannot create a virtual machine. So this whole kind of identity access authorization and authentication management is done by IAM. Okay, and yeah, so I mean, we could, there's not enough time for us to go in detail with all of these, but there's a huge amount of tools that are available. So one of the reasons why yeah, so one other thing I wanted to show what others available. So when you're working with Google, right, you get a terminal on from which you can access all these services. It's called a Cloud Shell, and it's going to take some time. So what this Cloud Shell is, that it will give you a, you know, a low-end machine for you to access and run all your commands if you want to create any resource. Now you can also set up Google Cloud Kit software developed SDK on your local machine and then use it. But instead of that, you can actually directly come here and then remember I said about I have this command here I used, right? Which one is it? Yeah, remember this one? This, if you want to create a machine, instead of from the UI, you can also do it using this command. If I take this command and run it here, it will kind of run. Okay, I don't know what that is. I didn't copy it, I guess. So yeah, so that's one thing. And yes, so the reason why I'm kind of gave this presentation is kind of encourage you guys to see if you're interested in learning Google Cloud technologies and then achieve one of those certifications that are being offered, and I can help you guide through the process. Okay, I think we can take questions.
Right now, we don't have any immediate questions. We'll just wait for a while and we'll see, Ram.
Okay. Now, there's one other thing that I want to to show it to you guys. Quicklabs.com. So what this provides is, if you want to learn some Google Cloud technologies, you can come here and then learn. Now, some of them, first of all, you have to create an account. I think I had an account, but I don't know. Okay, this is an old one. I don't know if this will work or not. Okay, maybe it worked. Now, what this provides is Quicklabs is actually, I think it's a Google-owned company now. It actually gives you some mechanism to learn some of the Google services. Now, what it does is it kind of a lab, a kind of an environment. Now it's asking, see here, it's asking 1 credit. So you have to kind of pay for this. But oftentimes what happens is, if you follow their Twitter account, they give out coupons. And then you can use those coupons and then join this and then learn your cloud. Or if you go to catalog, right, there may be some free ones that are available. Okay, check out for anything that is free and then see if that works for you, and then you can learn from there. Or go back here and then remember you have $300 credit. You can use that credit to learn stuff. I mean, just spin off some services, clusters, and then learn. I mean, this is part of learning. I mean, $300 will take you long. Okay, so this created a cluster, and then I'm going to delete it. So one thing you should remember when in cloud, if you are not using it, delete it. Okay, so as part of your learning, you create a resource, and once you're done, you have to delete. Otherwise, they'll keep charging you. Okay. So I'm kind of surprised that there are no questions.
Now we got some questions, Ram. Like,
okay,
Whitson will read out, then you can answer them.
Sure.
Whitson, please go ahead.
Yeah, sure. The first question, Ram. I have 10 years of experience in networking. Is it good to switch to cloud computing?
Yeah. Okay. So yeah, it's a very good question. I think you should, because see, this whole lot of virtualization happening in networking space too. I think you may be already aware of. You briefly addressed that software-defined networking and network function virtualization. Now, if you want to continue to be in that space, right, you may still want to learn about cloud, because you want to know about virtualization and all that stuff. And that even the network space is kind of growing, but however, there's now a much less demand for network engineers unless they are in the cloud themselves. There is there's still a lot of demand for cloud engineers with networking experience, because although you may not see it here, but if you have to integrate some of these services with third parties products, like configure FI switch or whatever with GCP resources or whatever, right, then these cloud technologies will really help you a lot.
The next question, way to start, do a certification of GCP.
No, I didn't get it.
Way to start to do a certification of GCP.
Okay, way to start. Okay, if you want to get certification, then you should obviously you should get familiar with. First of all, you should figure out what certification that you want to choose. You want to get certification in. And second thing, right, you need some guidance. See, there are a lot of free tools available. Okay, and then when I started learning GCP, I realized, okay, I can learn it myself. But then you need some guidance. Otherwise, what happens is you're going all around and then coming out with not much of progress, because time is critical. So what I'm working with Interskill team to develop a 2-month course curriculum to help people like yourself uh, help get certification. Now, our curriculum will be tailored for a generic Google Cloud certification, but we will cover pretty much 70 to 80% of all certifications, and rest of it, depending upon the kind of certification you take, you invest your time and go into DevOps or data engineering or whatever. So look forward to an email from Interskill team, and they get more details. And the thing that what I learned from everybody else is everybody wanted to learn from the free tools that are available, and they spent 1 year and they haven't gone anywhere. Because oftentimes somebody should tell you, like, guide you, okay, what path should I take, and then do it in the most time efficient manner. See, there's an opportunity cost in doing everything by yourself, right? So you do your own research and figure out everything by yourself, but with some help from like myself or from a coach, you get the guidance, you get professional advice, and then somebody to talk to, and that's what we are trying to do. So we are trying to offer a course that will suit your needs in GCP certification.
The next question, cost of GCP and how to become GCP admin.
Okay, there is no GCP admin per se. There is no course something called GCP admin, but you will be able to administer based on your experience. You can learn. See, uh, uh, people have been doing GCP for ages, right? But without formal training. I mean, nobody teaches these in colleges, right? So all those people who learned, they learned it by themselves and then relied on somebody's help. Now, if you want to become, you can't technically. There's no GCP admin, but pick up one of those professional architect kind of certification, and then enroll in a training program, and then we will help you get there.
In the next question, how about job opportunities in cloud computing?
Okay, now if you look at pick up any job that is being advertised, right? Every job is asking for some cloud technologies. They may not ask AWS GCP certifications, but they're asking for cloud technologies. Now, one way to achieve that is to pick up any certifications, AWS or GCP, and I'm kind of pushing for GCP, but that's up to your choice. Now, if you have to, if you want to boost your being employability and all that, right? Pick up certifications, Google Cloud certification or something like that. Build up the skills, and based on a recent publication that I saw, GCP certifications are the highest paid among all, whether it's AWS or anything else. They're the highest paid. So that's why I'm kind of pitching this. And one thing you have to remember, GCP certification is a bit harder than AWS or Azure. Okay, so take the tough road ahead. I mean, AWS, there are plenty of people because it's easier to get. GCP is harder, but with our help, you guys can achieve it. And it's very much high in demand.
The next question, what level of certifications can help us in GCP? Do I need to do advanced certifications?
So I didn't understand. So what kind of certifications you need to do for GCP?
What
So,
level of certifications? Is it advanced certifications?
okay. So okay. So there are. Let's go to that slide that I showed a while back about certifications. So you can see this slide. So you can start with associate cloud engineer. Okay, and then then move to either cloud architect or cloud developer or data engineer or DevOps. Now, DevOps and data engineer are a bit more specialized, and so is cloud architect. But cloud developer is pretty generic. Now, if you want to build expertise, right, start with associate cloud engineer and then move up. Now, each of these certifications, I don't know how much it costs in India, but in the United States, it's around $200. It's roughly, I don't know, like 15,000 just for certification exam alone. And these exams are not easy, I can tell you that. But we can help you coach for these exams. Yeah, does it answer your question? Or you have any further questions? If there are any further questions, let me know, because sometimes I find it difficult to interpret the questions that you guys are asking. So if you need to be further clarified, feel free.
Yeah, the next question, Ravi. To learn cloud, what are the prerequisites I need to know?
Yeah. So remember, one of the things that if you're learning, if you want to enroll in my program, I'll go through the prerequisites, because for example, right, how the VM virtual machine works behind the scene. I think you should know a bit about what hypervisors and how this networking is set up behind the scene. You should know something about software-defined networking. All these I'm going to cover in my forthcoming Google Cloud Certification program. And so you may think that you don't need to know all this, but at some point you're working as a cloud engineer and you're running into a problem, then you don't know how, you should know how to debug, and you should know what is happening, right? So these prerequisites are kind of essential. So virtualization, containers, Kubernetes. In fact, Kubernetes also is kind of prerequisite, because this is everything is on Kubernetes. Our Kubernetes like platform. Yes, if you're enrolling in interskill course, I will go through the prerequisites because they are important.
Next question, Ravi. Can a person who worked as a network backup engineer 7 years ago and have a gap, can she start learning cloud computing or GCP certified? What are the prerequisites to go for such programs?
Yeah, so see, these days a lot depends on your motivation. Okay, and I've heard people like they're sitting on their sofa and then opening YouTube and then going through videos, and then after like 1 year they haven't moved an inch. So what is needed is motivation, and then somebody to guide, or a coach to guide through the process. And as I said, we are here to help you out, and you can achieve it. And as far as the prerequisites are concerned, we will go through the prerequisites, because as part of our curriculum, you will be going through labs, which you have to do on your own with our guidance, of course. And that will actually a very good learning exercise, because it will be tough and painful in the beginning, but I think without sweating out, you can't get these certifications. I think in the real world, it will be a bit more challenging than what you actually go through. But then, because you need a holistic experience, like if you're stuck with something, right, you should know how to debug. That's kind of the fundamentals. So in our curriculum, we will go through the prerequisites and the fundamentals so that you have a strong foothold.
Yeah, the next question. Any quality assurance or testing related certifications in Google Cloud?
Unfortunately, no. Remember, one thing you should know, that that QA or testing as a profession is kind of dying. And it's dying for two reasons. One thing is there's a whole lot of automation happening. And then a lot of these services are moving to the cloud, because when you're moving to the cloud, right, there is already some expected level of consistency that is already there. And you won't have, you don't see your database malfunctioning. That can have on-prem, but on the cloud, there's no question of database misconfigured or database running out of space or something like that. So now testing it becomes very, very narrow that it kind of disappeared. Now, for those who are in testing, right, you should quickly migrate to cloud, because I think unfortunately for this QA developers, that job profile is going to vanish. I think it already vanished in the United States. I mean, if you think about these big companies like Google, Facebook, they don't hire QA engineers at all. So the sooner you migrate to a cloud developer, yeah, and you can move into clouds, because cloud technology is not like programming. Okay, it's able to understand cloud and being able to understand the services that are provided, and then being able to plug and put them in place. It's a lot like auto assembling of cars. Back then, the auto assembler need to understand how the carburetor works and all that stuff. But now everything comes in one piece. Now you just your skill depends on how you being a good designer, and then what tools are needed to put things together in place and then make it a solid module.
The next question. I have 12 years of experience in Unix administration. I'm planning to learn cloud technologies. Where should I start?
Well, where do I start? Yes, I mean, you should join our program, Inter-Skill Teams Cloud Computing Program, and then we will guide you there. Everything what you need. And then we will guide you to get a certification. And then once you get a certification, it's all about selling yourself.
Next question. Can someone with cloud certification without a professional college degree find good job opportunities?
Okay. Now, so certification is one thing, but then you have to supplement it with some real experience. But now, one good thing about cloud is that you have access to all the resources at one place. You don't have to ask or to depend on anybody, right? So it all depends on your practice. So our curriculum will actually include lab exercises. Now, this lab exercise you'll be doing on your own, but we'll tell you we'll give the steps on how you do it. Now, that will actually help you. Okay, be prepared to when you're actually joining a real company, you'll be actually very comfortable in taking up a job, and subsequently you will actually be selling that yourself.
I think the question is about having a professional degree. Like without a professional degree, can they get the job?
So without a professional degree, okay, that's see, in the United States, right? Nobody cares about degree, honestly. So I don't know in India how much they value the degree.
They value 99%.
Well, okay. See, I tell you, in the United States, in fact, even Google is hiring without any degrees. If you are a very good programmer, right, they'll hire you. They'll not check that. In fact, nobody has actually checked what my degree is. I mean, let's say if I bluff myself through, right? If I bluff that, I have a degree from IIT, nobody will actually question. I mean, nobody actually so far asked me, give me your degree certificate. Very rare. Okay, so that thing about not having a college degree is dying in the United States. Now, I don't know how India it is, but again, think about it. There's a guy. I mean, there are two guys. One has a degree, one doesn't have a degree. But then the guy without a degree is able to demonstrate that he has got cloud skills. You should ask yourself, who should they hire? All right. So I don't know the situation in India, but this is what in the US is. I mean, in the US, nobody is thinking about degrees. Although a degree may look good on your resume.
Yeah. Sorry to interrupt. Yeah, as Sudhir said, in India, we have not come to that stage where degree is not given importance, but we still have a lot of companies who care for degrees and which colleges are doing. If you do not have a professional degree as of now, while you are pursuing the certificate, pursue some degrees also online. There are now a lot of online degrees, some executive degrees, post-diploma degrees. So supplement your current degree with a professional degree. Professional degree need not be like, it can be something like a post-graduation course in data science, post-graduation course in cloud computing. Those kind of degrees are available now, which are much reputed. Go to Edureka or some online platforms, which are or greatlearning.com, which are actually providing these online degrees in collaboration with an online trainer plus IIT or NIT kind of combinations are there. If you need further information on that, just contact me personally for the lack of time. But generally, better to supplement your current degree with a professional degree in that particular course. That will definitely help you in getting a job in India. Okay, yeah. Over to the next question.
Yeah, the next question: if we fail in certification exam, will we get another chance or pay the certification fees again?
Yeah, so with Google, right, it's pretty rigid. You'll blow up $200 for every attempt. Now, as I was saying, Google certifications, okay, the way it works is like, I think they have like 50 questions and you need to get 70% pass. So they are hard, honestly, they're tough. However, so, I mean, here's the thing, right? You think you can learn it by yourself for free and then attempt the exam and then you blow up. And that is a lot more expensive. But then take some professional help, guidance, okay? And then put your own effort. And then hopefully you'll clear it. But each time, the flunking will cost you $200 straight out. Okay, so you don't want to do that, right? That's why you need solid preparation, and we can help you there. And yeah, you don't get a second chance for free.
Yeah, the next question: after completing GCP course, will I get job without experience?
Okay, so here is the thing, right? Let's say you're an engineer, you go to IIT, nobody guarantees you a job, right? With the skills that you've learned, I mean, you do an engineering from any college, nobody guarantees. There's nothing like guarantee. But what a lot of effort, at least we put in as part of training professional, is like gives you the guidance and then motivate you to build up the skill and the knowledge that is required. Now, although it may happen that you take the exam, you flunk, but then you take the exam again and then pass it and then build the skills. Now, once you have that certification, right, very few companies will question your skills, credibility. Because the certification is about establishing credibility. Once that credibility established, it should be easy to get a job. So if you take our course and then don't take the exam, right, I think you have to prove your credibility yourself. That will be resting on you. However, taking this, but the curriculum will actually tailor you to crack the interviews and whatever that is needed. But again, there's this whole other semantics that are out there, which I cannot provide any guarantees on whether we'll get a job or not. I mean, it's the same thing. I mean, if somebody is saying that he's going to promise you guarantee a job, he's bluffing, and we don't want to bluff, right?
Yeah. The next questions are similar. Already you have covered those. Yeah. One last question: GCP certification questions are objective or situations based? Any big global customers using Google Cloud?
Oh, any global customer using Google Cloud? Okay, Google has got almost 6,000, 7,000 customers. Okay, see, Google makes roughly 12 billion a year. That means every month they're making $1 billion per month. So you bet there are a lot of customers. Now, what's the other part of the question that you asked?
GCP certification questions are objective or situation based?
So GCP, I can tell you GCP, it's different, but the cloud architect The questions are situation based. They're the case studies, and because it's an architect level question, right? They'll give, but these case studies are published in advance, so it's not like you can study the case study before, and then they'll twist the questions based on the. So you're not going to get the same questions, right? So you have this case study, and based on the case study, you'll have some questions like, I want to do this, or this is the problem that the company is facing. Now, how should I solve it? So those questions are there for the cloud architect. Now, for the cloud developer, data engineer, and DevOps, it is multiple choice. But again, multiple choice is not like one answer. Sometimes a question would demand 2 or 3 answers that we don't know. Like, which of the following is true? Okay, check all that apply. So only 1 may be true, only 3 may be true, or all may be true, or none, right? So those kind of questions will be there. Plus single choice questions. So I think we are closing to close your time. Now, if there are any questions, I mean, if there are similar questions, we can skip them. If there are anything that is unique, we can still proceed.
Yeah, that's it, Rama brother. For now, there are no more questions.
Okay. Hey, okay. Thanks a lot for your time and effort. I know it's a weekend. You may want to enjoy with your family, but thanks for attending. And as always, we are here to help you out, build skills on Google Cloud Platform, and then help you through the certification. And watch out for emails from Interstill team.
Yeah. Thank you so much, Ram, for your valuable time. Like, I know it's late night for you in US now. It's around 11 o'clock, I think. I know, like, it is very much useful to all the participants who has joined. We have quick announcements. We have
Ravi,
another
want to
being.
make an announcement?
I think Ravi has delegated it to me.
Okay, go ahead.
I'll go ahead. Yeah, sorry. Yeah. We have another wing from Interskill called as Intercare, where we want to help the people, the professionals. Whitson, can you just share your screen? I don't know.
I should
Whitson,
stop
are you sharing?
sharing?
Yeah.
Can I stop? Okay. Okay. I
Yeah,
think it's gone.
please. Yeah. So this is our Intercare team. Like, if you need any help in career guidance or financial planning or emotional wellness, you can drop a mail to intercareteam@gmail.com, or you can register yourself at the tinyurl.com/intercare register. Our people will be getting in touch with you and they'll help you out for further support needed. And we'll be taking a break for next week. Next week, we'll not be having any session. On October 10th, we'll be having a session on cybersecurity, and we'll be sharing more information about the faculty and all very soon. And Whitson will be posting the feedback form in the chat box. Request you all to share the feedback. And you all please get registered to the Interskill team group so that we can keep you updated about the sessions that are going to happen very soon. And once again, we thank Rama for all your valuable time. We'll keep in touch with you. Thanks for your support.
Okay. Hey, take care, man. Take care. Bye.
Yeah, take care. Thank you. Thank you so much.
Take care. Bye.
Request all to share the feedback before dropping. And like and share our Interskill page on Facebook. Whitson, just hold on for 5 minutes. Then
Okay.
you can drop off.
Okay, sure. Thank you, Anna.